Antiderivatives of vector-valued functions. Suppose capital R of t equals the vector capital F of t, capital G of t, capital H of t, where f, g, h are the antiderivatives of lowercase f, g, and h of t respectively. Then capital R of t is the antiderivative of lowercase r of t equals lowercase f of t, g of t, h of t. So what this means is that we take our antiderivatives component-wise just like we did our derivative. Suppose lowercase r equals 2t cosine of t, t cubed. So to find the antiderivative, capital R of t, we take the antiderivative of each piece, so we get t squared sine of t, t to the fourth over 4. And we can check this by taking the derivative of capital R of t, and we should get back lowercase r. So looking at indefinite integrals of vector-valued functions, if capital R of t equals capital F of t, G of t, H of t, then the antiderivative of lowercase r of t equals the vector lowercase f of t, G of t, H of t. Then the indefinite integral of vector r, lowercase r of t dt, equals capital R of t plus c, where c is a constant. So, for example, if we're finding the integral of r of t dt, so if lowercase r of t equals 1 over t e to the t 6, then capital R of t, we find the antiderivative of each piece, gives us natural log of t, e to the t 6t, and so then we need to add a constant. So our integral of r of t dt equals the vector natural log of t, e to the t 6t, plus a constant c. Similarly, we can evaluate definite integrals. So if lowercase r of t equals lowercase f of t, g of t, h of t, provided that f, g, and h are differentiable on the interval a to b, then the integral from a to b of r of t dt equals the integral from a to b of f of t dt, integral a to b of g of t dt, and integral a to b of h of t dt. So let's try an example. Let's say we want to find the integral from 0 to pi of r of t dt, where r of t equals cosine of t, sine of t, 2. So we find, we're doing the integral component-wise, 0 to pi, the integral from 0 to pi of cosine t dt, integral from 0 to pi of sine of t dt, and the integral from 0 to pi of 2 dt. So evaluating each integral, we have the antiderivative of cosine of t is sine of t, evaluated from 0 to pi. Integral of sine of t is negative cosine of t, evaluated from 0 to pi. Integral of 2 is 2t, evaluated from 0 to pi. So we have sine of pi minus sine of 0, negative cosine of pi, minus minus, so plus cosine of 0, and then 2 times pi minus 2 times 0. So sine of pi is 0, sine of 0 is 0. We have negative, negative 1, plus 1. We have 2 pi. So we have 0 to 2 pi is our definite integral. Well, let's have you try one. So go ahead and try to find the indefinite integral of cosine of t, e to the t, 3t squared. Pause the video, and when you're ready, come back and check your work. So for finding the integral of r of t dt, where this r of t equals cosine of t, e to the t, 3 to the t squared. So we need to find our antiderivative, capital R of t. That is sine of t, e to the t, t cubed. So our integral equals r of t plus c. So that's sine of t, e to the t, t cubed, plus constant c.